Hi guys, it's Miss Aguilar. So I'm on to the third part of your final study guide, and we're picking up where we left off. And the last problem I did for you guys was the number one problem. Here we're at number two, and the question is: Shane and Austin are playing a one-on-one soccer game on the roof of the school. If Austin kicks the soccer ball horizontally, that's important, off the roof, which is 42 meters high, that's our delta y, and lands a distance of 75 meters from the edge of the building, this is our delta x. What is the initial horizontal velocity? Well, this is velocity in the x direction. And remember, the one thing about horizontal velocity is it's constant. So even though it's asking you to solve for initial horizontal velocity, any velocity in the x direction for this problem is going to give you the initial, the final, and anything in between. It's all the same. It's constant. Okay? So starting off, you should have your x and your y side. So we have delta x, we have velocity in the x, and we have t. I don't know if you guys can hear my TV or not, but my son is watching Moana. I should probably have him lower it. I'm at home right now, so. Okay, so we're solving for velocity in the x, but we have two values. We have delta x and delta y, so let's put those into our chart. It's 42 meters for the delta y and 75 for the delta x. Now it's asking us to solve for Vx, right? And how do we solve for Vx? Well, Vx is equal to delta x over t, except we don't have t. So let's just go to that one equation we usually start with, and it's the t is equal to 2 times delta y over t. I'm sorry, g. All right, so we have 2 times 42m over 9.8 meters per second squared. All right, so I have, for my top number, and then don't forget this is all square root. The top number is 84, and we're dividing it by 9.8. I sort of dropped off the units. Sorry. Remember, they don't really drop off. I'm saving time. So 84 divided by 9.8 is 8.57142857. I'm just going with 8.57. That is not the answer, though. Don't forget, there's one more step here. We have to do the square root, and that will give us our actual time. And then our time ends up to being 2.93 seconds. Okay? Let me just kind of erase this t right here because I don't want you to think that that was the t. All right, and remember, t is the same for both x and y. All right, let me just erase this real quick, and then I'll move on to doing the math for the other side, or well, the actual original problem. The original problem asked us to solve for the initial horizontal velocity, and so now we can do that because we just solved for time. Vx is equal to delta x, and that's 75 meters. And we're dividing it by the time, which we just solved for, 2.93 seconds. And this is just putting into your calculator, 2.93. And then velocity in the x comes out to be 25.6 meters per second. All right, there we go. Okay, next one. Melissa and Macy. If Melissa and Macy horizontally project a water balloon from the top of a 92 square high cliff. Okay, so here we go, 92 high and cliff. That is definitely delta y. Okay, that is representing some sort of vertical displacement or, up and down displacement. And it has an initial speed. Initial speed is always velocity in the x. What is the horizontal displacement of the balloon? So it's asking us to solve for horizontal displacement. Horizontal displacement is delta x. So we have x, we have our y, we have delta x, which we're solving for. We have velocity in x, which is 19.8 meters per second. And then we're solving for time probably because we don't have it. Delta y is equal to 92 meters. Velocity in the y, g, 9.8, well, negative 9.8. And then t. Again, here we go. We're doing the same thing we did before. Starting off with solving for t. T is 2 times y over g. So 2 times 92 divided by 9.8. I'm leaving out the negative because this is a time value and time cannot be negative. I'm just dividing right now. So it ends up to be 18.78. Well, we have up here meters and meters per second. So we have meter squared and second squared. Okay. Sorry. I was just thinking about something there. Okay, the square root. 4.33 seconds. I think maybe if I did the square root of this, then this would be meters per second, and that's not what this is. This top number is not squared. But is it meters per second squared? That's something I have to think about. Okay, just ignore the units for this one. For some reason, I'm going on a blank right now. But, okay, whatever. The answer to t is 4.3 seconds. Well, 4.33 seconds. Okay? All right, and now we have to solve for, again, what it originally asked us to solve for. We just had to, figure out, we just had to figure out time first. Okay, so now we have two variables in the x direction right here. That means with two variables, we can use those to solve for the third, and that's with any kind of algebraic equation. You always need two variables known. Now we have them. We have delta x is equal to v times t. The velocity is 19.8 in the x direction, multiplying it by the time, and it's 4.33 seconds. So we have 19.8 times 4.33, and that ends up being a displacement in the horizontal direction of 85.734. We can leave it at 73. 85.73 meters. There you go, that's your answer. I know it's all that work for just one little answer. It seems like a lot. Okay, let's end there. I'm going to try and keep these below 9 minutes. So I'll be moving on. There will probably be like 1,000 videos at the end of all this. So guys, remember to email me if you have any questions, okay?